Hello everyone. Let us divide some expressions with exponents and see where we arrive at. Let's start with this example. 3 raised to the power 5 divided by 3 raised to the power 2 or 3 squared. So what do we have? We have 3 repeatedly multiplied 5 times in the numerator. 3 times, 3 times, 3 times, this is 5 times, and we have in the denominator 3 into 3. So how do we proceed? We just cancel out the common 3's, right? So 3, 3, and so 9 is cancelled, and what are we left with? 3 3's, that is 3 cube or 3 raised to the power 3. Now one more example. Let's have square root of 2 raised to the power 5 divided by square root of 2. So for those of you who are not aware of what square root of 2 is, just treat it as a symbol or as a variable, like we use variables in algebra. So what do we have? We have square root of 2 repeatedly multiplied 5 times in the numerator, right? This is 5 times, and this is over a standalone square root of 2. So we cancel the common factors. This gets cancelled, and we are left with square root of 2 raised to the power 4. For those of you who are aware of what is square root of 2 will know to simplify what this is, but it is okay if you don't simplify. Just treat it as a variable and let it be like that. And let's have another example. 7 raised to the power 79 divided by 7 raised to the power 79. So the powers are the same, the bases are the same, and the powers also are the same. So what do we have in the numerator? We have 7 multiplied by itself 79 times. So we have 79 times 7, and denominator also we have 7 into 7 into 7. This is also 79 times. So it is the same number which is in both in the numerator and in the denominator. So what do we have when we have the same number in both the numerator and denominator? Just like your 2 by 2 or 3 by 3 or 4 by 4, this is also equal to 1, right? And now for the fourth example, let's have 3 raised to the power 3 divided by 2 raised to the power 2. Now the difference between the earlier examples and this one, if you notice, is the bases are the same. For the first one, the base is 3, second one, the base is square root of 2, third one it is 7. Here the bases are different. So let's see what we arrive at. You have 3 times 3 times 3 in the numerator and 2 into 2 in the denominator. This cannot be simplified. No common factors, nothing. It cannot be simplified. So I think you will have to leave it like this, right? So let's have one more, the last example. This is the fifth example. 5 divided by 5 to the power 4. I think you would have noticed the difference between the earlier ones and this one, but let's just do. So you have in the numerator a standalone 5. Maybe I can, since I am multiplying 5 just one time, I can write it as 5 raised to the power 1. And in the denominator you have 5 into 5 into 5 into 5 4 times. So 1 5 gets cancelled, and ultimately we are left with 5 raised to the power 3 or 5 cube in the denominator. So 1 by 5 cube is the answer. Now using all these examples, now let us generalize and arrive at a rule for this division in exponents. Let's not call it a rule, because you see that it is logically arrived at. What is a rule here? The last one also, multiplying powers with the same basis. There's nothing called, I don't know why it's called as a rule. It's just logic. So if you have a raised to the power m divided by a raised to the power n, this is what we've been following, right? A, the common base, a. So this is equal to, let me just simplify and see what it is equal to. I have in the numerator a repeatedly multiplied by itself. A is multiplied m times, right? M times. And what do I have in the denominator? This is over. Once again, a multiplied by this time we have n a's. We have n times. And for simplicity now, for the time being, let's assume that m is greater than n. So how many a's get cancelled? N a's would get cancelled, right? N number of a's would get cancelled, but you will be left with more a's in the numerator because we've assumed that m is greater than n here, and now we would be left with m minus n a's, right? So a raised to the power m minus n would be the answer. Now what is the rule which we have arrived at? Let me write it in red. A raised to the power m divided by a raised to the power n is equal to a raised to the power m minus n. But keep in mind that we assumed m is greater than n. It doesn't mean that it does not hold good for m is equal to n or m is less than n. We'll just revisit these examples and talk about this issue later, right? So what about the example 1? 3 raised to the power 5 divided by 3 squared. If you apply your rule here, a raised to the power m minus n or 3 raised to the power 5 minus 2 is equal to 3 raised to the power 3, and that is what you have obtained by division also. And what about the second one? Root 2 raised to the power 5 divided by root 2, and let's treat it as 1 because it's a standalone repeat, it's multiplied by itself. So it's root 2 raised to the power 1. So we have root 2 raised to the power 5 minus 1 if you apply this rule which we have arrived at, right? A raised to the power m minus n. So which would be equal to root 2 raised to the power 4. So the rule applies here also. I wouldn't call it a rule, it's a logic, right? And what about this one? Here you see a case of m being equal to n. A raised to the power m divided by a raised to the power n, where m is equal to n. Whatever it is, we have 7 raised to the power 79 minus 79 if you apply the rule, which is equal to 7 raised to the power 0. So 7 is multiplied no number of times. 7 is multiplied no number of times. So this is going to give you 1. Right? And this argument also justifies why 7 to the power 0 is equal to 1. And coming to the fourth one, this is a non-example because the bases are not the same, so you cannot apply the rule here. So we'll just leave it. And the last one. Now here you observe that it is a case of m less than n, right? And what if you apply this rule here? You have 5 raised to the power 1 minus 4, or you have 5 raised to the power minus 3. So is 5 raised to the power minus 3 equal to 1 by 5 raised to the power 3? We do not know as of now, but let me tell you just one thing. The law holds good for m less than n also, m equal to n also. So there is something more for us to learn here, and we will certainly do it in our following videos. As of now, this is the rule for dividing expressions with exponents with the same base. I hope you followed. Thank you.